Sketch the graph of y equals -4 cos of x divided by 2 below. Clearly label all axial intercepts, maximums and minimums with their coordinates. So when we're sketching a graph that doesn't contain any translations, so we just consider dilations and reflections, then we just really need to consider the period and amplitude of the graph. So if we look at the number that's multiplying the circular function out the front, then that will help us determine the amplitude. So for this graph, we have an amplitude that is equal to 4. So once again, if that's -4, the negative is actually just a reflection. So this negative here indicates that it's reflected. And the amplitude, which is the maximum displacement from the mean value, is 4. The other thing we need to consider is the period. And that is equal to 2 pi divided by n, where n is the value that's multiplied by x. So in this case, n is equal to 1/2. So our period is 2 pi divided by 1/2, which is equal to 4 pi. So with that information and the knowledge that no other transformations have occurred in terms of translations, so no translations horizontally or vertically, it's actually quite easy to sketch these graphs. So if we start with the fact that it's reflected, instead of having this curve, we're going to have something along the lines of this. And we can actually leave that there because all that's left now is to fill in the values of the maximum, minimums, and axial intercepts. So that is one period worth of the graph in the positive direction, and because we've got the negative half of the axes available as well, we'll sketch one period in that direction as well, so that'll be something like that. So on the glass, my sketch isn't great, but you get the idea. And now our job is to put in all of the key features. So this value down here is going to have an x value of 0 and a y value of -4. So that's going to be a maximum displacement away from the mean value of this function, which is y equals 0. If we complete one period worth of this graph, we know that that's 4 pi. So it's going to have an x value of 4 pi and a y value that is the same as down here at the other minimum of -4. Going in the other direction, we know that this must be -4 pi and still -4. And now the beauty of our circular functions is that they are symmetric. So that means that these maximums are going to occur halfway between the two minimums. So this is going to be -2 pi and +4 because it's a point of maximum displacement. So it's the amplitude's value away from the mean value. And then this is going to be +2 pi, and again, y is 4. Now, halfway between a maximum and a minimum sits an x-intercept. So starting in the furthest negative direction, we're going to have one at -3 pi, 0. Then this is going to be -pi, 0. This will be +pi, 0. And lastly, this will be 3 pi, 0. So that's our full graph sketched for 2 periods worth of the circular function with all the maximum, minimums, and axial intercepts labelled with their coordinates. So over on this slide, we've just got a computer to generate a bit nicer of a graph, but again, you can see that all the key features are the same that were on the previous slide.